Welcome back to another installment of my video lectures. This is Unit 9, Section 9.1, Distance and Midpoint Formula. So back in your early algebra days, we did the distance formula and said d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared if you were given two ordered pairs. So we're going to jump in and I'm going to show you two ways of doing this problem if you want to use the distance formula, or we can use method 2. So in example 1, it says find the distance between the points -2, 3 and 4, -1. So method 1 is we're going to use the distance formula. So I'm going to write down my formula. D equals square root x2 minus x1 squared plus y2 minus y1 squared. In the two ordered points they give you here, they gave you -2, 3 and 4, -1. Label those your x1, y1, x2, y2. And what we're going to do is we're going to substitute in to the formula those values. So now we see x2, which is a 4, minus, and then it's a -2, so I'm going to put -2 in parentheses, close it, plus y2, which is a -1, minus 3, close it, squared. Do the math here. And then we become 4 minus means plus 2 now. I changed the sign. -1 and -3 is a -4, power of 2. Do the math and sign. So I'm getting 6 squared plus a -4 squared. I'm just doing step by step. Here we become 36 plus 16. Which gives us the square root of 52. Now remember, 52, think of a deck of cards. A deck of cards is, there's 4 suits with 13 cards in each suit. So when I take the square root of 4, I can simplify this to 2 square roots of 13, and that is my distance. That was method 1. Method 2 is if you don't remember the distance formula, everyone remembers Pythagorean Theorem, which is a squared plus b squared equals c squared. If you had coordinate paper, plot your 2 points. So the first order pair is at -2, 3. And the second one is at 4, -1. I'm drawing straight edges, so it means I see a right triangle. And I'm going to count measures. We have 1, 2, 3, 4. This is the height of 4. 1, 2, 3, 4, 5, 6 is the height of 6. So remember I said Pythagorean Theorem. Well, remember a squared plus b squared equals c squared. So method 2. 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. That gives us 52, which then we can take the square root of again. And again, remember, deck of cards, that's 4 and 13. So we end up with 2 square roots of 13 for the same measurement. I have same answer, 2 different ways, 2 different formulas. You're probably wondering why we did this. It's because it's going to lead us into circles. Remember, this is distance and midpoint formulas, which actually gives us references to circles. So just give me a second. Remember from geometry that a circle is defined as the set of all points in a plane that are equidistant from a fixed point called the center. The fixed distance from the center to the edge of the circle is called the radius. So there's a formula called standard equation of a circle. That's if it's centered at HK with a radius of R. So it's going to be parentheses x minus h squared plus y minus k squared equals r squared, where r, which means radius, has to be greater than 0. A hint to remember that if the circle is centered at the origin, which is 0, 0, then h is equal to 0 and k is equal to 0, and the equation simplifies to x squared plus y squared equals r squared. Now look at this thing. This has a correlation to Pythagorean Theorem. A squared plus b squared equals c squared, which is the distance of a radius if we want to think about it. So if we look at example 2, It wants us to graph a circle. It says find the center and radius of the circle, then graph the circle. So I gave us an equation that says x minus 3 squared plus y plus 4 squared equals 36. Remember, your formula said x minus h squared plus y minus k squared equals r squared. And I'm going to line my equation up underneath. X minus 3 squared plus y plus 4 squared equals 36. If we remember back from when we were solving for vertex form, which was in the last unit, or 2 units ago actually, the inside tells us where we're going. So x minus 3, think of it as x minus 3 equal to 0. X is equivalent to 3, so that's my h. Y plus 4 is equal to 0, so y is equal to negative 4. That's your k. So the circle has a center at the point positive 3, negative 4. The circle is going to be centered at 3, negative 4. Radius squared is equal to 36. So I'm going to say r squared equals 36. R is equal to positive and negative 6. But remember, radius is unit of measurement. So only positives. So now we know our center point, and that from our center, you're going to radiate out 6 units for each of them. So I'm going to put a dot at 3, negative 4. But I'm going to make this in units of 2. So I'm going to use increments of 2 for these. So 3, negative 4, that's 2, negative 4. And then we're going to go 6 units north, south, east, and west from it. So 2, 4, 6. There's 1 dot. 2, 4, 6. 2, 4, 6. 2, 4, 6. So this is going to be a rough sketch, so bear with me. Normally you would use a compass if you or a protractor if you had one. So you do a rough sketch, and then we have a center that has, here's your center at 3, negative 4, and then the distance from the center to the edge is 6 units, which is your radius. For example 3, they want us to find the center and radius of a circle and then graph the circle. So in this one, they told us our formula for our equation standard form is x plus 1 squared plus y plus 2 squared equal to 20. So again, I'm writing my equation, x minus h squared plus y minus k squared equals r squared. Eventually, you're going to become proficient that you will not have to write down your equation. You're going to be able to pull your information. So I'm going to write x plus 1 squared, y plus 2 squared, 20. So remember, again, it's the opposite of what you see. So x is equal to negative 1, so that means h is at negative 1. Y is equal to negative 2, so the k value is negative 2. So negative 1, negative 2. R squared is equal to 20. So r is equal to the square root of 20, that you're going to use an exact value. And now this is not going to be something that's going to be feasible when you take the square root of 20. Remember, you're taking the square root of a number that's not perfect. So you're going to come out to be around 4.5 units, which is actually 4.47. It comes out to be 4.47, so I'm going to round up to 4.5 for it. And we're going to use the radius of 4.5. So again, you're going to put a dot at negative 1, negative 2. And then you're going to radiate out 4.5 units north, south, east, and west. So 1, 2, 3, 4.5. This time I only did increments of 1 unit increments, so you didn't have to collapse it. 1.5. 1, 2, 3, 4.5. And then you draw your circle. It's going to be a rough sketch. Remember, this is not pleasant to do. Okay? So, remember, the formula is already given to you. You just need to do the opposite of the sign of these and just take the square root of the value. So if we go to example 4, how do we take an equation and that's in standard form, expanded form, and collapse it to our circle formula? Give me a second. So in example 4, it says writing the equation of a circle in the form x minus h squared plus y minus k squared equal to r squared. It says identify the center and radius of a circle given by the equation. So in our equation, they gave us x squared plus y squared plus 2x minus 16y plus 61 equal to 0. First thing you want to do is group your variables together. So I'm going to rewrite it where I have x squared plus my 2x, and I'm going to put a blank. Plus sign between it, then I'm going to put y squared minus a 16y plus a blank. And I'm subtracting the 61 to the other side to make it negative 61. So, first thing you do is you're going to group your variables together, the x's together, add a blank, put a plus sign. Group the y's together, add a blank, equal sign, negative 61. Now, these blanks on the left, we need to have them on the right. And the reason for this is we're applying 7.1, which is completing the square. So remember the rules of completing the square. You take half of the middle number, so 2 divided by 2 is a 1, and then you square it. So I'm going to put a 1 here. I'm going to add a 1 on the left side, right side, to balance it. I'm going to divide by 2 and I get negative 8, which I square. I get 64. And I add a 64 to the other side. Now, if we had to factor out values and attach to the y squared or x squared, say there was numbers here, you would have to do the whole rule of balancing the left and right. Right now we don't. So now we're going to collapse our parentheses to a power of 2. X positive 1 because we squared a 1. That's where it goes. Bring a variable down. Y, it's a negative 8 because we squared to get to 64, power of 2. On the right side, I was short $61. I found $1, I'm short 60. But I found 64, I have $4. You are now in standard form. This is standard form right here. So remember to find HK, opposite of your sign. So we are at negative 1, positive 8. R squared equals 4, so R is equal to 2. And if then you had to graph it, then you would plot your center at negative 1, 8. And then radiate out 2 units north, south, east, and west for it.